introduction we have studied, the processor will be interrupted for the data transfer. Okay, so similarly for transferring input output data to the memory. Okay, it's not only for the data transfer from the input output device to the memory, there are multiple other steps also there, so that the processor can be interrupted, other issues also instead of just for transferring. So those are called interrupts to the processor actually. Okay, it's just like assume that interrupt service routine process, like see, for example, if you're cooking some food in home, or just like boiling the milk in the kitchen. So what will happen, that boiling is the milk is in the kitchen, is the processor doing some work. You assume that like that. Suddenly phone rings. What will you do? That you will stop the stove and you will go to the attend the phone, and again come back and you will switch on the stove. Okay, so that intermediately you are attending that phone call. Okay, meanwhile you are suspending the execution of the current program. Okay, this is the way interrupt service routine also works actually. Okay, whenever the processor is interrupted, okay, what will happen? Whenever some interrupted comes, what will do the processor will do? Processor will complete the execution of the current instruction. Okay, complete the execution of current instruction and suspend the program there, and it stores the next instruction and continuation of that program in some other location, so that it can later time it can resume the execution of the program. Okay, you see that instructions. Okay, instructions are there. Processor is executing one by one. Okay, you see that processor is executed. Suddenly it is interrupted. Okay, interrupted. What will it do? It will complete the execution of the current instruction. Okay, and it will store next instruction to be executed in the some stack. Next instruction to be executed means the program counter where it has to fetch the next instruction, because it has to fetch the next instruction from here. Okay, it will complete the execution of the current instruction and store the program counter to the stack register, so that later time it can retrieve the program counter and resume the execution of the program where it is suspended when interrupt has arrived. Okay, so it is just like temporarily suspending till the interrupt. So after receiving the interrupt, what will it do? It will deal with the corresponding interrupt service routine program. It's also a program actually. So processor jumps from here to the interrupt service program, somewhere it is written ISP. It is also a program, interrupt service routine program. Okay, interrupt service routine ISR. Okay, it will jump to this program. It will execute this program. Okay, after completion of this execution interrupt corresponding to the interrupt, for example data transfer interrupt, some particular device, so it will go to the particular location actually. Okay, that interrupt service routine, it will execute all the data transfer or interrupt service routine. In the completion, after completion of this interrupt service routine program corresponding to the concerned interrupt, what will it do? It will again load this program counter to here, and it will fetch the instruction from here. It will start resuming where it is stopped while before interrupted. Okay, it's just like doing some other program corresponding to the interrupt. Okay, intermediately, just like while boiling the milk, going to attend the phone. Okay, intermediately you stop boiling by switching off the stove. Okay, you just attempt that attend the phone, and you come back. Okay, just like it will stop the program where it's in, it will go to the interrupt service routine, and again it resumes. By loading it will continue the execution. Okay, just like continuing the boiling of the milk. This is the interrupt service routine. Service routine is nothing but for each interrupt. For example, different devices are there, different of types of interrupts are there. So for each interrupt there is a program. For example, if there is input output data transfer, there is some particular program to continue to do how to do the data transfer. If there is a power failure, there is a corresponding program what to do. Okay, so that is called interrupt service routine. Interrupt service routine is nothing but it's a program. Okay, it's a program to what to do that to particular interrupt. Okay, you understand that. Okay, now you see that interrupts are two types: external interrupts and internal interrupts. External interrupts are like power failure, external device communication, input output device communication, low voltage, all these are external interrupt. Internal interrupts are, for example, in a program if it has to divide by 0, okay, that's an internal interrupt. or hardware failures. Hardware, there is some hardware circuit is failed. That's also an internal interrupt. Okay, you have to remember for each type of interrupt, whatever the interrupt, there is a interrupt service routine. Okay, interrupt service routine is nothing but what to do when that interrupt occurs. Okay, so the processor will execute that interrupt service routine always, and again it will resume the execution of the current program depending upon the intensity of the program. Okay, you'll see the one by one. Okay, and allocation of the process time, this is also interrupt because processor will run the multiple programs at a time. Okay, when a process is running for longer time, not continuously, it's not ending, it's running for the long run, it also has to be suspended because it's running longer time. Okay, indefinitely. So that process has to be closed. At that time also interrupt will be generated. Okay, long running process. Okay, you will see that more detail all these things. External interrupts. Okay, an external input device, usually when will it get it? Will get it external interrupt mostly for input output servicing. Okay, input output devices for data transfer. So what will happen when input output device interrupts the program? When interrupt the processor, what will do that? Processor will fetch the required interrupt service routine and it will complete the required data transfer. Okay, that's why it will do that. Even power failure also, it will fetch the corresponding location and it will show when the power failure interrupt occurs. Okay, what will power failure means? It will store the all the current data so that it can resume when the power turns on again. Okay, so that execution will be done. Input output device, power failure, low voltage. Okay, like the device hardware internal failures. Okay, divided by 0 occurs. It will, what will happen? It will show the program counter, accumulator and results to the, it will print to the output, and if that error is not serious, it will resume continuing that program. Okay, if it is serious, it will stop there itself. Okay, then again hardware failures. So what will happen when a hardware failure occurs? Some logic circuit has failed. Okay, some logic, some AND gate or something failed. So what will happen? It will go to the corresponding interrupt service routine so that the hardware checking codes will be there. It will check the error generates, it will generate the errors and check the hardware it is working for perfectly or not. So if it is can be corrected using correction code of that hardware failure, there is error correction codes will be there. If that hardware failure can be corrected using error correction codes, then the program will resume normally. If it is not able to correct, then it will stop the showing that hardware failure. Okay, like that. This is also okay. So you have to remember, for all the interrupts there will be an interrupt service routine and there will be the execution of that will be done. After that, it will processor will start the normal process execution. So other than that, there are multiple input output devices. Okay, you know that. So that there will simultaneously there can come multiple interrupts. Okay, so how will you handle? There are two ways to handle that multiple interrupts. One is software solution, another is hardware solution. Okay, first we'll see the software solution. Whenever an interrupt occurs, what will happen? There is a program, interrupt service routine program, and the processor will check which, depending on the priorities will be there. Okay, based on this interrupt is priority interrupt, this second priority, third priority, like that. So it will check the first priority first priority device, whether that device has interrupted or not. Okay, if it is not, it will go to the second priority item. Like that, it continuously check all the devices, which device has interrupted. After deciding which device has interrupted, it will find out there are multiple devices. Okay, it is a software program. Whenever an interrupt occurs, it will check priority 1, priority 2. Okay, devices, it will check one by one. So for example, this device is interrupted. Okay, this particular device is interrupted. So what will happen? It will stop the, it will go to that interrupt service routine of this particular ESE. Okay, it will go to the interrupt service location of this particular input output device. It will do the required thing. At the same time, while doing this, it will suspend interrupt disable. Interrupt disable it will set. What does interrupt disable means? Interrupt disable means is nothing but while executing this interrupt service routine, there are no new interrupts will not come, because it is not allowing interrupts, so that no new interrupts will come. Only after completion of this program, interrupt enable will set. Okay, this way this software solution works. This is less expensive. Okay, you understand, software is a program. Actually, whenever an interrupt comes, it will check all the interrupt devices, in the interrupt enabled in the priority mode. This is first priority, highest priority interrupt device. Second priority, it will check whether it is caused the interrupt or not. whether it is, so it finds which devices cause the interrupt, okay, and it will disable the interrupt disable pin it sets, so that no further interrupts comes while servicing this interrupt. So it will go to this particular device and it will do the interrupt service routine, and again it will interrupt enable pin will be set, so that next instruction will come. This is a software solution and less expensive. Now will same can be done with the hardware way. How can you do that? There is a register, okay, for a disk, for input device. See, disk is an input output device, CD-ROM input, power failure. For each one there is an independent bit will be there, okay. See that, for example, power failure comes, this bit will be set to 1, okay, like that. So when multiple, for example, simultaneous power failure comes, this bit will be set. And mask register means if you are not want to allow this one, like that means there is an AND operation. You understand that? For example, you can understand like that. Take this power failure. You want to avoid this power failure. Even that power failure comes, you don't want to consider that. What will you do that? You will mask it. Mask it means what happens? Mask it means there is a mask register. That programmer can do that. Okay, programmer can, what can you do in mask register? What the programmer will do, for example, you don't want to allow this power failure interrupt. What will he do? He just make this particular location corresponding to that power failure 0. Then what will happen? Even that interrupts comes in the power failure and that particular bit is set. What will happen? This bit and this bit is AND operation. Okay, here comes 1 because there is a power failure, but here you don't want to allow the power failure, you make it 0. Masked power failure. So what will happen? Ultimately it is 0. That means no interrupt will be going to the end location. Okay, if you want to allow this one, for example, if you want to allow this one, what will happen? You will set to 1. That means this is already 1. That means whatever, whether it is set, for example, this control is set, you are not masked it, you are allowing it because you are set to 1. Okay, so to allow the interrupts, you set that corresponding bit location in the mask register to 1. To not allow, you make it 0, so that interrupt will not be considered. So for example, disk you set 1 mask register, so you are allowing it. So whenever there is a disk failure occurs, okay, then corresponding bit in this will be set, mask register also set, so 1 by 1 it goes. So what we'll see that there are multiple interrupts are there. We just taken for example 4 only. Okay, when multiple occurs, for example at a time 3 occurs and 3 are also enabled, not masked. So what will happen? 3 will be highlighted simultaneously. So then comes the priority loss, because when there are multiple interrupts are there, you can do the service to the only one interrupt. So there should be a priority logic, because when multiple interrupts occurs, which one we should serve the priority. So based that priority 1 interrupt, priority 2, priority 3, priority 4 interrupts will be generated. Okay, so depending on the priority, if priority 1 is set, that interrupt corresponding address, there are interrupt service routine programs. I told you for each interrupt there is a interrupt service routine program for each interrupt. So that what will happen? This encoder will generate corresponding address of the interrupt service routine program based on the priorities. Okay, this is the way hardware solution works. Okay, this is all about interrupts. You see that interrupts are nothing but interrupting the processor working. Okay, there is interrupt service routine. Interrupt service routine is nothing but it's a program actually, just like attending a phone. It's like executing some instructions. Okay, there are internal interrupts, external, internal, and there are 2 ways: software solution and hardware solution to solve the interrupts. One more: software solution and hardware solution to the allocation of the interrupts.